invite Professor Goto to introduce
谢谢
his work. So, microphone, please.
谢谢大家早安，我是清大的 Tomo。今天我想介绍我们的小小的实验，用电影学习物理。但是我的中文不好，所以我讲英文，不好意思。Before starting, I want to thank my TAs, Terry and then Darian. They are very good TAs, although they're not here. They are presenting posters here. Terry says he found a planet 9, and Darian is simulating alien invasion. So that's interesting. So if you have time, please take a look at their posters. And also, I want to thank MOE and NTHU Center for Teaching for their support for this project. Okay, let's get started. Okay, these are the TS. Okay, we have a common problem. So we have this in our class, and this in our class, this in our class, and eventually this. So the motivation of this project is how do we keep students interested in physics? And then one of my answers is to use movies, because students are interested in movies, so they don't fall into sleep in a physics class. And then, yes, they can focus on learning physics. And then maybe famous professors will frown upon what you want to watch movies in physics class. However, if you look around the world, this example is very popular around the world. For example, in North Carolina, there's a physics class called Matrix to Mission Impossible. And then in Yale University, there are movie physics. That's a real class. And also in Charleston College, there's a class called Apocalypse to Warp Drive, Physics in Film. I want to attend this class. So it's actually popular in the world. So why not in Taiwan? This is not working? Oh, sorry. Thank you. Oh, this is better. So I gave students an assignment. This is the assignment. So please select unphysical movie scene and explain what's wrong. So that's the assignment to students. And these are the movies that students picked. So they're probably you are familiar with these movies. They are famous movies. And from here, I want to show you some example student presentations, the selected ones. Let's start from the first student. So I show you a movie scene that student picked, and I have a quiz for you. So this student picked something wrong in here. So what's wrong? Okay, let's watch the movie. So in this movie, there's a space elevator, so an elevator to go to the space station. Okay, let's watch it. So that space elevator, and the enemy is going to destroy, and then space elevator is destroyed. So what's wrong here? Any idea?
Can we see that again?
Yes. Of course.
It's a bit short.
Any idea? It's too short?
In the space?
Yes, this is a space elevator from the Earth to space station, and then it's destroyed by enemy.
Fine. I think so. The last the scene from the last. So when the ropes are still burning, but the elevator still sliding on the ropes. I think that might be something.
Oh, that's a good point. That's another probably problem. But what student picked is that this is a counterweight of space elevator is falling onto the Earth. That's incorrect. But before showing the answer, you guys woke up, right? So as soon as I show you the movie, all students look up the movie, right? So that's the point of this project. Okay, and then let's listen to, so this student said this is a counterweight of the space elevator, and that's falling onto the Earth in the movie. And she says it's incorrect because the space elevator, how it works is there's an elevator here, and then there's a counterweight of the elevator, and the elevator is of course pulled by the gravity, and then this counterweight should pull to the other direction by centrifugal force, so to keep the tension, to keep the balance, right? So if you cut it here, this should fly away because this is already above the geostationary orbit. So this pulling power is stronger than gravity, so it should fly away. And then she explained that and then also showed a movie. So this movie, she created this movie about the explanation. So it should fly away. It should fly away. I didn't notice that, so I was amazed by the student presentation. Okay, let's go to another example, another student presentation. So this is a movie called Indiana Jones. Do you know? Have you watched Indiana Jones? Okay. And then in this Indiana Jones, there's a nuclear explosion near this Indiana Jones, and he hides into the refrigerator to survive the nuclear explosion. So later, there's a nuclear explosion, and he is hiding here. Who thinks this is a fake? Who thinks Harrison Ford is going to die or he's going to survive? It is fake. So one student actually calculated. He calculated the radiation from a nuclear bomb, and then he calculated, actually that refrigerator is made of lead. So it has some shielding effect from the radiation. And then he calculated the shielding, and then he concluded if the refrigerator, the thickness is 6.7 centimeter, then Indiana Jones can survive. So this movie is not totally incorrect. Yeah, that's too thick for a refrigerator. But it's amazing, it's not totally a lie. So, okay. And then another example is this example. Spider-Man stops the train with 6 spider web. Can he do that? And then he calculated that actually the spider web is kind of very strong, more than we think. And then he calculated how much the force is needed to hold the train with that speed. And he concluded that if Spider-Man had 17 threads, then Spider-Man can stop the train. So 6 is not enough. So he needs more threads. Then he can stop the train. So that was also interesting. So these are the presentations. And then at the end of the student presentation, I asked students to make a Kahoot quiz. This is an online quiz, and everybody in the class is going to join this quiz, and then it's a sort of competition. For example, here's a quiz. This is from the Indiana Jones movie, the quiz from Indiana Jones movie, and to maintain stability in a raft, they needed to distribute their something evenly, and then the answer is, which one? Yes, of course. Thank you very much. Yes, wait. And then at the end of many quizzes, we have this banjan. And then because I'm a teacher, I want to be number 1 here, but I'm here. I'm here. Some students are smart. Okay. And then this is the result from the questionnaire at the end of the semester, and the students think this Kahoot quiz helped to review the knowledge. And then 70% students said yes, and then it also helped the interaction. 70% of students said yes. So I think this Kahoot quiz was very good to increase the questions and the interactions. Let's look at more results from questionnaires. Then I think one of the important points is teacher's suggestion. Because students present their ideas in the movies, but then if just let them do that, then they are limited to what they know. So I think it's my important role to suggest students to go into more advanced topics. So I thought this was a good responsibility, important responsibility for me. And then good reaction, good interaction, 87% students yes. So the class was very happy and fun. And then the motivation went up, 80% students said yes. So that's good. That's what. And this is comparison to other classes. My class is this red one, and then this is NTHU average, the blue one, and then my class is mostly doing better than average, especially this student-teacher interaction and then creative assignments. So that's good. And then there are some student comments. Student said, 老师人真好, so that's good. He is very smart and funny. Thank you very much. And then, so some students are interested in learning physics from movie, so that's good. And the most important comment is this: 老师幽默分主帅. So I was very happy. Okay, then I'll summarize. I think about the time. So I try to include a movie, and then student motivation went up, so that's good. No one was sleeping. And then Kahoot quiz, I think this was very good to increase the interaction between teacher and student. And then my important responsibility is to give them good suggestions to go deeper in physics. I think this is very important responsibility for me. And then in the end, I learned, did you get inspired to learn physics by movies? And then 94% of students said yes, so that was good. I stop here. Thank you very much. Thank you very much.
Yeah, and comments.
Yes.
So thank you very much.
Thank you.
Actually, I just want, would you please give us more details about teacher's suggestion for students? Get some guidance or get some more.
Well, first of all, I need to correct them if they are wrong. So some students misunderstand the concepts, and then the presentation physics is not correct. Then I need. It's very important for me to find it and then fix them. Like for example, they need, I don't know, when they need to calculate the pressure. Sometimes students calculate force. These two are very different. So these kind of things. And then whenever I try to suggest students go deeper into, I don't have a good suggestion, but say if something. So for example, this Spider-Man. So students are calculating just the weight of the force on the spider web, right? But then there's more important things. How do you stick the spider web to the train? And then what about his arm? And I suggested this to students, and it turned out the Spider-Man's hand's gonna broken, before stopping a train. Because this may be strong enough, but this human hand, is not strong, right? So this is one of the examples of the suggestions.
My another question is actually as we are trying to instruct students understanding about the nature of science or the nature of physics, we always need to avoid give right or wrong answer to students.
Mm-hmm.
For example, we always tell maybe or try to give more uncertainty context for students to understand. In the future, as you are an engineer or a physicist, as you encounter a problem, you have to understand actually we do not have totally right or totally wrong answer for any problem solving. So how would you do that for your suggestion giving?
In that sense, I think these are good examples. So instead of 6 cannot stop, students came up with the answer that he needs to increase to 12. I think this is going to be the more practical answer. So I thought I like that. And also the refrigerator example, instead of, Harrison Ford dies, he increased the thickness of the lead. So that's, I think, the direction Professor suggested, I think.
Thank you.
Thank you very much. Okay.
Unfortunately,
Thank you very much.
I think many people in the audience would like to discuss this with us.
Thank you.
Unfortunately, time is up. So let's